So are all the planets in our solar system similar? Why or why not? What does similar mean? Go ahead.
They're the same shape, but they have different sizes.
Okay, same shape, different size, right? Okay, same shape, but they have a different size. Okay, and you can see that from all these different planets. They're all circles, right? Or they're all like a sphere, but they're all different sizes. Okay, so today, and this is what I would write on my notes if I were you. Up at the top, I would write, prove all circles are similar. So up at the top of your notes, I would write, prove all circles are similar. So every day you're going to have a slide that looks like this. And I would title my notes whatever this slide says. Okay, because that's what we're going to talk about. As just a side note as well, to take good notes, I would date your notes. I would say like 8-8 in the top right-hand corner.
What's the AKS?
Like the number? AKS like 5.
Where, Lula? Where?
Just write prove all circles are similar. That's okay. Okay. Actually, the AKS number is 53. Sorry. All right. So on your computer, okay, you have access to this presentation slide. I want you to open up this document. So this is on slide 3. You're going to open up this document. Okay. And what we're going to do is we're going to answer these questions on our piece of paper, but we're going to use this little exploration tab right here. Okay, so we're going to click on this little exploration tab. All right, and I want you to take about 30 seconds, and I want you to kind of like interact with the applet. Okay, so take a second, play around, figure out what it's doing, and answer those 2 questions on the previous page.
It's on E-Class or
It's on E-Class.
W.
Okay, so go ahead and take a moment. Okay, so let's take a look at it together. Ready? Okay, so when you kind of toggle this, okay, it moves to the left and then it increases in size, right? Okay, so let's use some math terms to describe what's going on. Okay, when it moves to the left, what's a math term for that? Translation. Yes, y'all learned something last year. I love it. Translation. Okay, so that means it moved to the left. Okay, now, once we moved it to the left, what happened next? It dilated. Okay, so it increased in size. Okay, so coming back over here, what does this applet demonstrate about any 2 circles? What does this applet demonstrate about any 2 circles? There's similarity. Okay, so they're similar shape, but different size. And then how do the transformations you saw help you support your response to question 1? So how do we know that they're similar? Well, go ahead.
How much you change properly form the shape, it's gonna remain.
Okay, so remain the same shape as well as we laid one on top of the other, right? Okay. All right, go ahead and take a second and try exploration number 2. Okay, so go ahead and open that tab, interact with it, and see if you can answer those questions. All right, so taking a look at this one, let's look at what happened. Okay, so in order to move circle A and circle B, I'm sorry, you have 2 circles, circle A and circle B. See if you can transform circle B so that it matches circle A exactly. Okay, so if I want to get circle B onto circle A, what do I need to do? Okay. So go to the right one. Just kidding. It just keeps moving. There we go. Okay. And then what do I do now?
Actually, no.
Go on.
And then you're gonna go down about, yeah. And then you're gonna go to the SF slider and then
Oh, little off. Ta-da. Okay. So horizontal moves it left and right, vertical moves it up and down, and then the scale factor dilates it, right? Okay, so coming back over here, it says, were you always able to match the circle? Yes. Okay. Are circles always congruent? No. What does congruent mean?
you have the same size.
Same shape, same size, right? Okay. Not same size. Are they always similar?
Yeah.
How do you know?
Because circle is the same.
Circle is the same shape. And you can kind of manipulate that size and that dilation to make it lay on top of one another, right? Okay, let's go ahead and take a look at the last exploration. Okay, so what you're gonna do is you're gonna open up this third application. Okay, real quick, let's go over some terminology. What's a radius?
Radius is the distance from the center of the circle to the
Center of the circle to outer. Okay, or for those of you who are like visual learners, looks like that. Okay, what about a diameter? Go ahead. Okay, so through the middle of the circle, straight through, or 2 times the radius, right? What's the circumference? Okay, the distance around a circle. Okay, so it's like walking the perimeter of the circle, right? Okay, so what I want you to do is using this little applet, okay, you're going to manipulate the radius and it's going to tell you what the circumference is. Okay, so for instance, if we're here, it tells us that the radius is 2. What would the diameter be then? 4, because we're going to do 2 times the radius, right? Okay, circumference, we're going to go back into our little applet. We're going to change the radius to 2. What is the circumference now? 12.57. So we're going to go in here. We're going to say 12.57. Now in these last 2 columns, it asks for some ratio. So that's going to be R divided by C. Okay, so 2 divided by 12.57. What is that going to give me? 0.159. And then I'm going to take my circumference and divide it by my diameter. And I'm going to go ahead and tell you that that's 3.14. Okay, so what I want you to do is spend a little bit of time filling in this chart, and then we'll talk about what the answers are. Okay.
Paper?
Yep, you're filling it in on your paper. Let's talk. So for diameter, all that you're going to do is you're going to take the radius and multiply by 2. So that's going to give you 6, 8, and 10, right? Okay. For circumference, some of y'all were asking me, you're going to use the applet for that. Okay, so you're going to come in here and you're going to change the radius to 3, and that's going to give you 18.85. 18.85. And then you're going to take 4, and I'll go back to the other page in just a second. And that's going to give you 25.13. and then you're going to take 5, and that's going to give you 31.42.
Is the formula for define circumference diameter times pi?
2 pi r or diameter times pi. That's fine too. You're going to be a little off, but yes.
A little off.
Like the rounding might be a little off, but that's okay. Yeah. Okay. So now these last 2 columns are really important. Ready? This is the part you want to pay attention to. Okay. R divided by C. When you do this, you're going to get 0.159 for every single one of these. And this last column, when you take the circumference and divide it by diameter, you're going to get 3.14. Guys, what's 3.14? That's exactly what it is. Okay?
How many numbers of pi do you know?
I used to know about 150. What? I don't remember all of them anymore. I haven't had to do it in a while. Okay, so based on that information, you ready? Based on that information, can you prove that all circles are similar?
Yes.
Okay, why? The ratio are all the same for R divided by C and C divided by D. What can you conclude from the final column? And we already talked about this, that C divided by D equals pi, right? Okay, and he just asked this question. He said, hey, circumference formula. The circumference formula is pi times diameter, right? If I wanted to solve for pi, guess what I would do? Divide by diameter. So C divided by D equals pi. Okay, so do we need to recap on that? Okay, so really quick. This column is 3.14. We've already determined that that equals pi, right? Okay, then you know from hopefully last year that circumference equals pi times diameter. You remember that? Vaguely? Okay, if you wanted to solve for pi from this formula, you would just divide by diameter. And look at what this gives you. What this column is, right? Okay, that's proving that they are all similar. Okay. Taking a look at that question down at the bottom, I know it's kind of hard to see, so you might want to pull it up on your laptop. Okay. It says, Serena drew 2 circles as shown below. The radii of the circles are given in centimeters. The length of a chord of the smaller circle is 4x minus 5, and the length of the corresponding chord of the larger circle is 8x minus 11. What is the scale factor between these 2 circles? I want to give you a minute to kind of think about this. Somebody in my last class asked me, what's a chord? So just in case you didn't know, a chord is a line that goes through the circle but doesn't pass through the center. Okay? So like this would be a chord. Okay? All right, so go ahead and take a moment. Think about this problem down at the bottom. Think about what scale factor is. All right, you ready? Okay. You ready? No? Maybe. Yes. Okay. So scale factor is how much we're multiplying by in order to make it bigger or smaller, right? Okay. So they tell us that we've got this one circle and its chord length is 4x minus 5. Okay. Then they tell us we got this other circle and that corresponding chord length is 8x minus 11. Okay. So what do? How do we figure out scale factor? Go ahead.
I need to set it up as the equation.
Set it up as an equation.
So 4x minus 5 is equal to 8x minus 11 minus 5.
So you're saying 4x minus 5 and set it equal to it? Are they going to be equal?
No.
Why?
Mm.
They're similar, they're not congruent. Exactly. So what are we going to do? If we want to find the scale factor of something, like for instance, let's go back to this little applet. There it is. Okay, so how are we going to divide this? Scale factor is found by taking the post image and dividing by the pre-image. Do y'all remember those terms? Okay, post image divided by the pre-image. So what's the post image in this instance? 8x minus 11. So we're going to take 8x minus 11 and divide it by 4x minus 5. And that's it. That's all we're going to do. Nothing crazy. Okay. Now what they did down here is they gave you like the radius to just give you another option for for figuring out the scale factor. But if you took this right here and you multiplied it times this, you would get x plus 1. We're not going to do that right now because I think that's a little too much. We're just going to leave that alone. Okay. Okay. So going back to that other PowerPoint, I'm going to post this question up on the board in just a second. You should have some sticky notes around your desk. Okay. We're going to do something called sticky bars. Okay. And what I'm going to do is I'm going to ask you a question. There's going to be 4 different options. On your sticky note, I want you to write your name. Okay. And you're going to stick your sticky note next to the letter that you think is the correct answer. You do have to write a reason on your sticky note though. Okay. So for instance, oh, I'm sorry. Before we do that, I was jumping ahead. Okay, before we do that, we're going to write the transformation that would map B onto A, proving that they are similar. So how do we move circle B onto circle A? Go ahead, Jordan. So this has a radius of, well, this has a radius of 1, and this has a radius of 2. Okay, so there's a dilation of 2. Okay, what else happened? Translation. How?
It's rotated.
Right 5. Okay, so I'm hearing a combination of things. So really quick, I moved to the right 1, 2, 3, 4, 5, and I moved up 1, 2. Okay, so back in last semester, your teacher taught you this. They said if you were going to move it right, it's going to be x plus 5, and you're going to move up, it's going to be y plus 2. And sometimes if they have the dilation, they would put that 2 out front. Does that look familiar?
No. Yeah.
No? Okay. So this is just taking a coordinate, so like x, y, and making this transformation happen to it. So it's saying move it to the right 5, move it up 2. Yeah? Nothing crazy. Yeah. Okay. Okay, so now you're going to take your sticky note, okay? And I want you to answer this question that's up on the board. You need to put some type of explanation. Putting I don't know, or I'm not sure, or it's because, Courtney says so is not right. Okay? Yes. Huh? Okay, if y'all need sticky notes, they're right over here on this desk. Okay, so if you want to send somebody. Okay, so if you're in my 7th period, which you all are, you should go ahead and type this in. For 4th period, obviously this isn't y'all right now, but if you were watching this video, there's the code. Okay. So you're typing that in. Once you get signed in, okay, and I'll put this back up in just a second, I need you to go to your assigned stuff, which is circles vocabulary. It doesn't take that long. You'll be fine. It's not long. Okay. Go ahead and take a couple of minutes. You're going to be working on this. We are going to continue this tomorrow, but you have time to go ahead and start on it. Okay.